Assalamualaikum warahmatullahi wabarakatuh. This is Dr. Muhammad Hafiz, and today I'm going to talk about our final chapter for this course, BET1303, which is chapter 8, Magnetism. So there will be 4 subtopics: magnets and magnetic fields, magnetic force on electric current, magnetic force on moving charged particle, and finally, magnetic field due to current carrying charge. So I'm sure everyone knows what a magnet is. Magnet was first observed around 2,500 years ago in iron ore near the city called Magnesia. Now it is called Manisa. So this is where the term magnets come from. So this iron ore is an example of a permanent magnet. When the people during that time, they put this iron ore on top of water, floating water, and they found out that the magnet will float showing the North Pole. So that's how they discover magnetism. The interactions of permanent magnets or compass needles, this is the iron ore compass needle tadi tu lah, can be described in terms of magnetic poles, north pole and south pole. So basically there are two poles in a magnetic bar, in a permanent magnet lah. We have a south pole and a north pole. So I'm sure you also know about this juga. If we put both of the same poles together, they will repel each other. North and north will repel. But if we put different poles together, they will attract each other. But what will actually happen if you cut a magnet into two? As we know, magnet has south pole and north pole. So if we cut into two, does this mean that this magnet will become fully south pole and this magnet will become north pole? The answer is no. When you cut the magnet into two, they will each create a new magnet with each with its own south and north pole. So same thing, if you cut it here and cut it here, again we will create 4 magnets, each with its own south and north poles. Okay, so this is actually similar with electricity. In electricity, we have a positive and negative charge. So the same thing with magnets, we have a south and north pole. However, there's a big difference between these two. In electricity, a positive electric charge and a negative electric charge can be isolated. They can exist without one another. For example, if I say that there is a proton or electron here, so that means that there exists an electron over here. You don't need a proton. But if I say I have a magnet with the south pole over here, then there must be a north pole over here. There cannot be exist a magnet with only the south pole or only the north pole. So that's the big difference between magnetism and electricity. So charges can be easily isolated, which means that they can exist on its own, just the positive charge or just the negative charge. But an isolated single magnetic pole, for example, only south pole, has never been observed. So in chapter 7, we have used the concept of electric field. For example, if we put a positive charge somewhere, then there will be electric field all around it. And the electric field will point out away from the positive charge. For example, from positive, it will point away. And if the electric field starts here, then it will point away. If the electric field starts from here, then it will point away from the charge. If the charge is negative, then it will always point towards the negative charge. For example, if it starts here, then it points here. If it starts up here, then it will still point into the negative charge. Okay, so what about magnetism? What about magnetic field? In magnetism, there is also something called a magnetic field. And the magnetic field also works similarly as electric field. So if we have a magnet bar with the poles north and south pole, then the magnetic field will point out from the north pole. It goes out from the north pole into the south pole. So similar like electric field from positive towards negative. So in magnetism, from north towards south pole. Okay, if I ask you a question, what is the biggest magnet on Earth? The answer is actually the Earth itself. The Earth itself is a big magnet. So that's why we have an Earth magnetic field. It is the pattern of a field line, of a magnetic field line, as there were an imaginary bar magnet inside the Earth. So this is our Earth, and this is the imagination of the magnetic field inside the Earth. Okay, since the north pole of a compass needle points north, the Earth's magnetic pole is the south pole. So if you notice here, this is the north pole from our usual understanding lah, dekat kutub utara kan, on north. So that means that it is the north pole. However, magnetic wise, it is actually the south pole. Magnetic south pole. So that's why our compass will always point towards the north because it is attracted to the south pole of the magnetic. So it is terbalik. So please remember that lah. Remember that the north pole of one magnet is attracted to the south pole of another. Okay, what is the SI unit for magnetism? So the SI unit for magnetic field is Tesla. It is in honor of Nikola Tesla lah, a scientist. Another unit is sometimes used, which is Gauss. So either we use Tesla ataupun Gauss, where 1 Gauss is equal to 10 to the power of negative 4 Tesla. And 1 Tesla is also equivalent to 1 Newton ampere over meter and equal to 10 to the power of 4 Gauss. So from here on,